common gate stage. As explained in example, in a common gate stage, the input and output nodes are isolated if channel length modulation is neglected. For a common gate stage such as that in figure, the calculation of example suggested a transfer function. Figure common gate stage at high frequency V out by V in of S is equals to Gm by GMB RD by 1 plus Gm plus GMB RS I 1 plus CS by Gm plus Gm plus RS power 1S into 1 plus RD CDS. An important property of this circuit is that it exhibits no Miller multiplication of capacitances potential, achieving a wide band. Note, however, that the low input impedance may load the preceding stage. Furthermore, since the voltage drop across RD is typically as much to obtain a reasonable gain, the DC level of the input signal must be quite low. If the length modulation is negligible and calculations made quite complex, recall from chapter 3 that the input impedance of a common gate topology does not depend on the drain load. If lambda equals 0 from equation, we can express the importance in looking into the source of M1 in figure. As Zin is similar to ZL by Gm plus GMB R0 plus 1 by GMB, where ZL equal to RD1 plus CDS. Since Zn now depends on ZL, now it's difficult to associate a pole with the output node. Figure A and B, that is V1 is equals to minus V out CLS RS V in by 1 plus C in RSS. We also observe that the voltage across R0 minus V1 equals to V out R0 equal to minus V out CLS minus GM V1 minus V1 is equals to V out. Substituting for V1 from equation, we obtain transfer function V out by V in into S is equal to 1 by GM R0 by R0 CL C in RSS square plus R0 CL plus C in RS plus 1 plus GM R0 CL RS into S plus 1. The reader can improve the body effect and be indicated by simply replacing GM with GM plus GMB as expected. The gain at very low frequencies is equals to 1 plus GM R0 for Zn. We use equation by replacing ZL with 1 by CLS, obtaining Zn equal to 1 by Gm plus GMB plus 1 by CLS into 1 by Gm plus GMB R0. We note that as CL or S increases, Zn approaches 1 by Gm plus GMB, and hence the output pole can be defined as omega p in 1 by RS 1 by Gm plus GMB Cn. Why does Zn become independent of CL at high frequency? This is because ZL lowers the voltage gain of the circuit, thereby suppressing the effect of the negative resistance introduced by Hiller effect through R0 figure. In the limit ZL shorts the output node to ground, the R0 and R0 affects the input impedance negligibly. If a common gate stage is driven by a relatively large source impedance, then the output impedance of the circuit drops at high frequencies. This effect is better described in the context of cascade circuits. Thank you.